So far we've been talking about future value, where we start with the principal P, we move it forward through time, and we know that every time we pass through a compounding event at a rate R, we pick up this little term 1 plus R. So now our goal is going to be to reverse this green arrow. Okay, so we want to start with the final amount that we want. So we're going to say we want some value S, and we're going to pull that money backwards through time. And we want to figure out what is the formula for this? How do we actually achieve this? The best way to do this is with an example. So let's suppose that we earn 5% interest at the end of the month. And our goal is to make $20. So how much should we invest? So let's start by drawing the diagram, and it's going to be the diagram that we had above. We have this little compounding event here at 5%, and we want $20. So our question is, how much money should we invest in order to ensure that we achieve that $20 amount? So let's let P be the principal, and we don't know what it is, right? That's what we're trying to figure out, so we're just going to keep it as a variable for now. And after 1 month at 5%, we know the formula for S, and we're going to sub S is equal to 20 into there, and this is what we get. And we can solve this for P. So we're going to divide both sides by 1 plus 0.05, and you can work out what that is, and you get $19.05. Great. And it's less than $20, and that makes perfect sense. It should be, because we know that interest causes things to grow. So far this has been a very algebraic treatment of the problem. And instead, I'd like to think about it as moving money through time, and again, moving it backwards through time. And the best way to do this is to draw that diagram. So I'm going to repeat that diagram that we have above. So we've got this compounding event R, and we know that our final value needs to be S. Let's find the principal P we need to achieve this. And we know what the formula is, right? It's S equal to P times 1 plus R. We're going to solve that for P to grab this. Now, I want to write this in a slightly different way, and hopefully you'll see why in a second. I want to write this as S times 1 plus R to the power of -1. Okay, so we're going to take that to be our present value formula. And the note to make here is the following. So whenever we pass through a compounding event at a rate R, if we're passing through it moving forward in time, we pick up this 1 plus R factor. Now, if we move it going backwards through time, we do pick up the 1 plus R, but this time the exponent is negative. Okay, so moving forward in time, we pick up 1 plus R. Moving backwards in time, we pick up 1 plus R to the power of -1. Now immediately, let's just generalize this to the end payment case. Last time we had done this in a separate video, but let's generalize to the end payment case. The easiest way to do this is let's draw a nice big diagram here. I'm going to draw in, let's say, 4 compounding events, and let's say they all compound at a rate R. So we're going to start with an interest rate S, and I'm going to put that after the 4th compounding period. Now you'll notice here I've drawn it just a little bit to the right of the 4th compounding period, and that's just going to make it so that it's a little bit easier to see when we've actually passed through one of these compounding events. So that's just a matter to make things a little bit easier to see. And so let's move S backwards, and again I'm going to put it just in front of the 3rd compounding event. Since we've passed through a compounding event R, but backwards in time, we pick up this 1 plus R to the power of -1. And we're going to repeat this, so now I'm going to bring it back again to the end of the 2nd compounding event. I pick up another 1 plus R to the -1, so now the whole thing is 1 plus R to the -2, and we can keep on doing this until I arrive back at the beginning of time, so this is the left of the diagram here. Now, notice that the power is 1 plus R to the -4 at the beginning, and that's because we've passed through 4 of these compounding events. So we can say that the present value of an amount S, which is compounding at a rate R over n compounding terms, is this, which is exactly the same formula as the future value, but we have this negative exponent. And again, the n shows up because that's how many compounding periods we pass through, and the exponent is negative because we're moving backwards in time. Now, I mentioned this at the beginning of the video, but one way that we can think about the present value is as the amount necessary in order to achieve the value of S that we want, right? So if someone tells you how much money you need to earn, the present value tells you how much money you would have to invest. So let's do a slightly more complicated example. Let's suppose that you need $1,000 at the end of the year, and you invest in a fund which returns an APR of 20%. compounding every 5 days. Now that's a slightly weird number. The question is, how much money do you have to invest at the beginning of the year to earn that $1,000? So there are several things to consider here. The first is we haven't talked about APR in the context of present value, but that's because we don't have to. We already know how APR works. To figure out the term rate, you take your total rate and you divide it by the number of compounding periods. It's no different with present value. It's exactly the same consideration. But the second thing is that the number of compounding periods being every 5 days is a little bit weird. We haven't done that yet. So we're going to have to figure out how many times this thing compounds in the year. Okay, so before we can do anything, we need to determine the number of compounding periods. We know that there are 365 days in a year. So if we divide that by the frequency of the compounding period, that tells us that there are 73 compounding periods total. Great. Now we can figure out the term rate. So we're going to take our 20% and we're going to divide it by the number of compounding periods. And I'm just going to leave this the way it is because the number is a little bit nasty. And now all we have to do is we're going to plug everything into our formula. And we're going to need a calculator to figure out what this is. But if you do that, you get 818.95. Great. So that covers our basics of present value, and we now have the tools necessary to move money both backwards and forwards in time. And we'll see in future videos why that's useful and how we can use that to help us out.